Hello, I'm Carter Penley, CEO of Penley Research and Development. This is our second video. In this video we're going to have a few talking points and reasons how and why we build better product, what our philosophy is, what our theories are. And these are sort of a long process, and I'm going to go ahead and use my notes if that's okay with you guys. Otherwise you're going to be sitting here all day while I fumble around. So this is a 15 or 20 minute video. I want to try to get through it, but I want to give you all the information you need right off the bat. We don't have to redo this thing or mess it up too bad. So talking points here are the 5 reasons why Penley manufactures the highest performance golf shafts in the industry. As the 5 reasons are: highest quality aerospace materials available, consistent design and development progression, most accurate machining tolerances, small lot production runs, and advanced design concepts. And the first of these we'll go into is going to be the highest quality aerospace materials available. All carbon fiber materials labeled as aerospace materials because in the beginning aircraft companies were the only government and the government were the only primary consumers because of the very high cost. But now there are commercial grades like for the sporting industry. These grades of carbon fiber exhibit the following though: less stringent quality control, larger toe counts for cheaper manufacturing cost, reduced mechanical properties, and less expensive matrix and epoxies. Many prepreg companies produce aerospace grade materials, but one carbon fiber prepreg company was selected to produce prepreg for a major U.S. aircraft manufacturer, and that company is also Penley's supplier. The quality of their product is absolutely the best, and that's why we use it. Plus, they have the best quality assurance program in the industry, so they know exactly what they're doing. To illustrate some of the requirements by some of these companies I have to deal with, then the vendors, they require a certified LOA, which is in its body states the following. This one item, this is a page of things I have to certify, and here's 2 items right out of that page. Penley certifies that he will never resell, retransfer, or export the goods or their replicas. That's the parts we make from it, or try to make parts like it, materials like it. Penley certifies that he will never use the goods for development or manufacture of weapons of mass destruction, such as nuclear, biological, chemical, and missiles. The second part of this process with materials is the oven curing process at Penley is very critical. And the items that the reasons for that is how we go through is to get a better, dense, construction. So the curing processes involve Penley cures at higher temperatures. That gives me better cross-linking, better density. Penley's cure cycles consist of 3 specific program ramp-up rates, soak times, and a controlled ramp-down rate. Again, to control that curing process so it doesn't cure too quickly and cause a lot of I guess you could say more of the curing of the process, so the molecular product doesn't connect properly. We don't miss that part of the program. It's very important. So the curing process gives us the best parts. Penley's precision curing processes and methods produces a golf shaft with better micromechanical properties, higher density, and less internal stresses. The second item on our list: consistent design and development progression. I'm the chief engineer and designer of all Penley products. Therefore, no break in deviation in design theory or philosophy. And all design advances are carried forward to the next generation of golf shafts, benefiting all Penley customers. A drawing specification sheet does not fully define the quality and or the performance of a golf shaft. Penley knows that not all manufacturing processes and methods are published, but do exist. This information is referred to in the trade as tribal knowledge, or formally as described as proprietary information. That is why no one can build a Penley golf shaft with the same quality performance as Penley does, not even if they have access to the original drawings and specification sheets. And that leads me to another little subject real quick, kind of a sideline. Last video we talked about counterfeits. That's been a big problem for me over the years, and clones. Although people can counterfeit, one thing they cannot do is build a product the way it's supposed to be built. That isn't what they do. What counterfeiters do real well, that gets them through, a lot of times it gets them to sell products, even though they're not making original product, is the fact of the packaging. They make the package look exactly like the manufacturer does, the original manufacturer. So you can't tell the difference. A few years back, Ray Bestos had a bunch of brake pads going very bad in the field, a lot of trouble. They went and looked at them, and they were buying these brake pads, Ray Besto brake pads from the distributors, but they were getting them from another source now, another supplier, who happened to be a counterfeiter. But you couldn't even, not even Ray Bestos could tell the difference in their package and the counterfeit ones. So that's what they do well. They don't make the product well. We're trying to ferret those guys out, and we're trying to get rid of them. I've spent considerable time and money with attorneys, with the customs, and we're chasing down everybody we can. All penalty golf shafts are original designs, as are shaft decoration and color schemes. I respect all other designers' designs, decoration, and color schemes, never stealing from others. Stealing designs is a sign of intellectual deficiencies. We just don't do that. If I can't beat you with what I design and develop out of my head, my originality, then I shouldn't be doing it. I ought to get out of the business. Penley has invented, that's the company and myself, designed and manufactured some of the more sophisticated test machines and methods for improving for golf shafts, performance, quality, and fatigue rates. So fatigue rates have to do a lot with the durability of the shaft, and we'll get into that later in other videos. Penley initiated and still is the leader of the feel process, hence our trademark, Feel the Power, that we trademarked back in 1999. The feel process is designed and machined into each and every golf shaft through Penley's proprietary designs and machining and T-bar algorithm. In another video, we'll get down and we'll get down into talking about T-bar and Z-Flex characterizations, and I think we mentioned those here in some of this process, but we'll get deeper into that later. It's more of a technical sort of thing for designing and manufacturing. Doesn't mean a lot to tour players, and a lot of club makers really don't really want to know about it or have any interest in it, but I'll explain it to you so you have an idea where we're at and how we get there. And I think you'll see some interest in that alone. The third item that was on the list is the most accurate machining tolerances. That is very critical because of the T-bar algorithm and the mathematics that goes into the Z-Flex characterization. Penley's developed and practices the tightest machining tolerances in the industry. All Penley golf shafts are machined to the center 1/3 of all flex ranges. Penley was the first golf shaft manufacturer to commercially implement multiple flex ranges within a single flex range. It was very popular with a lot of the club builders years ago. They could select a S shaft or an R shaft that was a 1, 2, or 3, the 3 being way on the stiff end, the 2 being in the center of the range, tip and butt, and the 1 being the soft R. Some people want to get a soft R, they don't want an A, but they need something a little stiffer, so we have those ranges. So we've kind of expanded on that. This process has now been refined and referred to as T-bar and Zone Flex characterization, offered by no other golf shaft manufacturer, as a matter of fact. This machining process yields a very tight tolerance and requires 15 to 20 inspection markers, resulting in 500 to 800% more machining time required than any other manufacturer. That's how much more we put into it. We've got to make it right, and most of my customers, demand that. They want the best, and they'll accept no less. This operation is akin to hand making each golf shaft. As you know, years ago, the very first golf shafts were wood. Wood is a composite material, just a natural composite material, resins and fibers from the tree branch. And so carbon fiber is just about that same item right now. All we're doing now is we just have a little easier process because it's more controllable than tree limbs were. But they had to do the same thing we do now, or if they want to do a better product, they have to. They would hand sand and hand file and hand work these shafts, wooden shafts, till they were just perfect for the player. It required a lot of time. So now with carbon fiber, we can do practically the same thing if you want to take the time. So I want to take the time because that's the way I make a better product. This process assures that each and every Penley customer receives the most exacting golf shaft possible. Penley designed golf shafts using the T-bar algorithm are designed and manufactured net to a flex range. I can't make an S and sand it down to an R. I can't make an X and sand it down to an S. I can't start out making S's and have them end up as an X because of material problems or something that wasn't done by our process here. They're no longer useful to the player, so they go in a trash barrel, or maybe out to the local farm where they raise tomatoes, and they put them in the ground and make tomato vine carriers for them, more like wooden posts because they don't rot. I'll go into more detail, as I said, about in another video about T-bar and Z-flex characterization, and you'll get a better understanding of all of that. Small lot production is the fourth item. Small lot production, purchasing small lots of pre-preg carbon fiber ensures that production materials are fresh and within certification, and ensure the following. Correct materials are accurately selected and verified per golf shaft drawing specifications. Patterns are more accurately cut and verified per golf shaft design and dimension. Design revisions and drawing changes are more quickly implemented. Manufacturing and or process problems are discovered early on prior to thousands of shafts being manufactured incorrectly. That quality and tolerances are more accurately maintained throughout all levels of production. So whenever we're cutting in smaller lots, we have opportunities to catch problems quicker and sooner. More than just not wasting a lot of material, it's correcting that process before it gets out in the field, because through production, those improper manufacturing processes start slipping. They cause tolerance stack. They start stacking up on you. By the time you get to the end, there is no fix. So we solve that problem quick. The object here is to limit the opportunities for process failures and losses and particles, and practice the art of theories of constraints throughout the manufacturing cycle. I'm trying to slow down a bit here for you. I get going too fast because I'm afraid the video's going to be way too long, but hang in there with me. The fifth and last item is advanced design concepts and results. And the results are enhanced control, distance, accuracy, consistency, and feel. The evolution of Penley's design concepts has reached a new defining plateau. The newly designed ET2 has a propensity to resist inconsistencies in the golfer's swing, thereby enhancing the player's game and score. A well-known tour player once told me all he wanted was a club that would give him the best miss hit. This guy was a pretty good player, and he was pretty accurate with that statement, because all players don't have the same day every day. They might get a club that plays pretty well for them, they like it, but one day their game's a little off, and all of a sudden the ball's really going left and right on them a lot. What we worked on was developing shafts for some of these tour players that they could kind of be a little off, but the ball's going to stay in the fairway. That's absolutely critical to a tour player, to a guy who makes his money playing this game. And to a lot of amateurs who want to play it well, it's very important. We want to give you the best product, the same product the tour players get, we want you to have too. During the player's golf club swing, the golf shafts are subjected to multiple outside forces induced by the player, such as bending and twisting at the butt section on the back swing, and on the downswing there's a rapid inertial transition coupled with high torque and deflection loads in combination with compression and tension loads at the mid to lower section of the club, all compounded by the player. The ET2 has been engineered and designed implementing T-bar to react negatively to the player's inconsistency, therefore improving on the club's dynamics, allowing the golf club to travel a more accurate, stable path through the swing plane and come at a more positive and squared strike zone with increased energy and control, yielding the distance and accuracy. Yielding more distance and accuracy. Those are the 5 items that we go by, or my basic philosophies, and in summary, a better golf shaft by Penley through advanced knowledge, analysis, and aggressive research and development, and exposure to some of the best players in the world in 30 years of golf experience get us there. Penley golf shafts are the highest quality golf shafts in today's market, and Penley maintains this position through advanced designs, materials, machining processes, all practiced by no others, and quality standards practiced today. And 100% manufactured in USA. That's the main thing. So that is basic, the video on the 5 points that we use to develop and manufacture a better shaft. And I'd like to give you one more piece of advice. That's have a little humor every day. And a lot of guys I deal with now and then tell me these little jokes, particularly golf jokes. One gentleman I know pretty well, he's a good customer of mine, I've known him for a while. He passed on a joke to me I'd like to tell to you, and I think I can do it. But if I don't do it right, John, give me a call, and you can tell me how bad I was. Just so happens the story's about a guy named Bill. Bill was retiring pretty soon, and before he retired, he loved playing golf. He thought he'd learn to start making clubs for himself, making his own components. And he did that, and for a couple of years he was doing very well, very happy, going out to the golf course to his club a couple of days a week, just having a good time. One day he comes home and he doesn't look all excited, a little dejected. And his wife says, "Hey, Bill, what's wrong? You don't look real happy today." And he said, "Oh, honey," he says, "I don't know." He says, "I think I got to stop playing golf. I just can't play golf anymore." She goes, "Why? What happened? Building your own product? You love this? What could be so bad?" He said, "My eyesight. I can't see the balls going anymore. I'm losing. I lost 2 sleeves of balls today." She goes, "Oh, that is bad, Bill." He says, "You know what? George down the street, he plays a good game of golf. He's got very good eyesight, you know." And he was in a store the other day. I was there, and he was reading all the little print off the boxes in there. So why don't you invite him to go to your club with you a couple times a week, you know, and you guys can play golf, and he can see where the ball goes. And Bill said, "Boy, that's not a bad idea. I think I'll do that." So Bill calls George, and George agrees to meet with him next Wednesday, and they're going to go out and play a game of golf. They get out to the first tee, and they get out there, and Bill says, "All right, George, I'm going to drive her down there. You go ahead and keep an eye on it for me, okay?" He says, "No problem, Bill. Knock her away." So he goes out there, and he knocks on straight down the fairway. You know, he can't see where it went, but it went down the fairway, he figures. And he said to George, "George, you see where it goes?" And George said, "Oh, yeah, I saw right where it went. No problem." He said, "Okay, George, tee up. Let's get on down there." So George tees up, hits one. They jump in the golf cart. They head on down. And Bill's looking around, and says, "Well, I got to find my ball." He says, "Did you see where it went, Joe?" And Joe says, "Oh, yeah, I saw exactly where it went." He looks, "Well, where did it go?" And George looks at him and says, "I don't know. I forgot." Anyway, so John, if I made a mistake with that, yell at me. Anyway, thank you for dropping in on this video. I enjoyed talking to you about a few things. We'll get into some of the actual activities and testing we do, and be able to show you how we come to some of these conclusions and develop some of this product, and how we work T-bar, and how we work the durability process into to golf shaft building and designing, so that you get a product that lasts and plays the same every day. So thank you again. Until the next video, you know, good luck and good golfing. Goodbye now.